Claremont, and this is my physics lab number 5 on the falling slinky. Introduction. The purpose of this lab is to analyze the motion of a falling slinky and create a model for this motion using code. I used Tracker to place the markers to observe the falling motion of the bottom of the slinky, placing all of my points at the direct bottom. For the code, I used GlowScript and modeled the motion. The result: the slinky first compressed, completely shrinking down to the smallest state it could before falling. So it stayed in the same place in the air before compressing, and then it accelerated, hitting terminal velocity and falling to the ground. Fundamental principles used: Newton's second law, where the change in momentum, where the change in momentum is directly related to the net force, with the equation. The drag force equation used to slow down the falling speed of the object, and gravitation force to attract it to the Earth. This is the observed motion. Our starting mass is 2.18 grams. Our reference height is 1.75 meters, and our starting point is practically right at the origin that I placed, pretty much. These are the initial conditions in the code model, with our mass here, our initial position, our time step, gravitational constant, and the drag force, which I found using trial and error. This is the model for the slinky compressing. The work is equal to the tension force on the slinky at this point, where the slinky is not falling at all, so the net work is 0. And therefore the slinky's velocity does not change, and the slinky's position will also not change while the slinky is falling. So after the slinky compresses, we have to calculate the work done the weight force done by the Earth on the slinky, and the drag force is counteracting it in the opposite direction. And there we have the net force, which is now a negative value. The ball's velocity then is updated, and so is its position. Here are results. The model and observed data are relatively close, but the observed data is relatively sporadic and has a lot of planes that probably shouldn't be there. This is probably present from me placing the points at bad intervals, and the frame rate not being exactly perfect. Okay. What would happen if a large mass was attached to the end of the slinky? If a large mass was attached to the end of the slinky, it would depend on the K value to pull it back up, or it would either fall if the mass was too heavy for the spring force to keep it in place, or it would stay in place if it was large enough. Thank you.